What up? It's your boy C Rizzy coming back at you with Unit 3, Lesson 2, Properties of Parallel Lines. Our objective today is to use properties of parallel lines to find angle measures. Our essential understanding is that the special angle pairs formed by parallel lines and their transversals are congruent, supplementary, or both. So this section is really just an extension of 3.1. Except now, instead of just learning about what same-side interior angles are, corresponding angles, alternate interior, alternate exterior angles, we're actually going to give them angle measures. Okay, so the first thing we have to note that these theorems, again, or postulates or theorems, things that are proven true, are true if and only if the lines that the transversal cut is parallel. So you'll notice these arrows here, okay, with singular arrows on the line. These arrows denote, so one arrow denotes parallel lines. All right, so we have two parallel lines being cut by a transversal, right? This is our transversal. Transversal, got to have this vocabulary down. So if my same side interior angles being cut by a transversal with parallel lines, then they are supplementary. So 4 and 5 are same side interior angles, they're supplementary, so they add up to 180. 3 and 6 are supplementary, they add up to 180 as well. Okay, same kind of idea. Now let's put a measurement to our alternate interior angles and our corresponding angles. So if two parallel lines are being cut by a transversal, our alternate interior angles, right, the ones that were on opposite sides of the transversal, but interior, are congruent. So 4 and 6 is equal to one another, congruent to one another. 3 and 5 are equal to one another. And all of my pairs of corresponding angles are congruent, as well as my alternate exterior angles are congruent as well. So again, we learned about these angle pairs, but now, if given that these lines are parallel, meaning they go on forever and ever and ever without ever touching, my alternate interior angles, my alternate exterior angles, and my corresponding angles are congruent, while my same side interior angles are supplementary. Okay, here's that proof that we've been talking about, right? A lot of different ways that you can write a proof. It could be a paragraph proof, or you just write it out. I always go with the 2-column proof, where I put my statements and my reasons. So my first statement in any proof is what I've been given. A is, now these little dashed lines, we've talked about this before, it means parallel. A is parallel to B, that's given to me. All right, well, if A is parallel to B, I want to prove. So the last statement of my proof is what I'm trying to prove. And I'm trying to prove that 1 and 8 are supplementary. So here's 1, here's 8. I want to prove that they will add up to 180 degrees. All right. Well, if I got 1 and if I've got parallel lines, that means angle 1 is congruent to angle 5. Why is that true? Well, because they're corresponding angles. And we just proved, or we just learned, that corresponding angles are congruent to one another if and only if A and B are parallel, which they are. So what's next? So now I know 1 and 5 are equal to each other. I also know that the measure of angle 5 plus the measure of angle 8 is equal to 180. And that's because they are a linear pair. Okay? We don't have to prove anything with linear pairs, right? If you have a straight line and two angles being divided on the straight line, that makes them a linear pair, so they have to add up to 180. Well, if that's true, and I know 1 and 5 are equal to each other, well then the measure of angle 1 plus the measure of angle 8 has to equal 180. So what did I do that? What did I just do here that allows me to swap 1 and 5? So all I did was swap these two, and the reason for that is because I said in the previous statements, well, that if 1 and 5 are the same, then I can use substitution and just swap them out of the equations. So therefore, my last statement to every proof is what I'm trying to prove. Angle 1 and angle 8 are supplementary. And this is not a hard reason. The reason I know they're supplementary, well, I just proved it in the last statement because 1 and 8 add up to 180, so that's the definition of supplementary angles. I'm just going to abbreviate supplementary and angles. Supplementary angles. Okay, so there's a little quick 2-column proof that shows why 1 and 8 are supplementary to one another. Okay, so you can always find the measure of all 8 angles when 2 parallel lines are being cut by a transversal. So again, there's my parallel lines. Here's my transversal touching all 8 angles. And the reason for that is because let's say that angle 1 here is 55 degrees, which it is, because 1 and this angle, that's 55, are vertical. And we've proven that to be true. Well, then 5 must be 55 because 1 and 5 correspond, or because the 55 and the 5 are alternate interior. And well, that means the measure of angle 7 must be 55. Why? For a bunch of different reasons. You could have done vertical angles. You could have done corresponding angles. You could have done alternate exterior angles. Now, the one thing to note here is that the angles that are congruent to each other make a little zigzag, which is kind of cool. So you can always kind of zigzag your way through and know which ones are the same. So let's go through this. Why were 5 and 7 equal to each other? Again, same reason. They're vertical angles. That's what we just talked about. Okay. 5 is 55 because it's, we'll say, alternate interior to the initial one. Alternate interior angles. The measure of angle 2 is 125 because it's a linear pair with angle 1. Right, here's our linear pair that we talked about before, right? These angles have to equal to 180. And then again, we get this other little zigzag where 4, 2, 8, and 6 all have to be 125 degrees. So the reason, if 2 was 125, then 4 is 125 because 2 and 4 are vertical angles. And 5 and 6 are 125 because of, we're going to say, vertical angles also. But in reality, we got to 5 and 6, or 6 and 8, because this little zigzag. So everything the purple touched was 125 degrees, and everything that the blue zigzag touched was 55 degrees. What is the measure of angle 3 and 4? Which postulate justifies your answer? So, I know that if this is a transversal, with P and Q being my parallel lines, well then angle 3 is equal to 105 degrees by alternate interior angles. And angle 4, so now I have a different transversal coming down this way, right? And this is hard to see because the transversal is sideways. So alternate interior angle. So what I'm going to do is I'm going to erase this and watch this. I'm going to rotate this picture so that it almost becomes a little bit easier to see. So now how about this? Now what if all of a sudden this line becomes my transversal, right? What's the relationship between 4 and 105? Well, the measure of angle 4 plus the measure of angle, or plus 105 degrees has got to equal 180 because they're same side interior angles. Same side interior angles are supplementary, so the measure of angle 4 then has to be 75 degrees. And if you really wanted to get crazy, you could actually figure out all of these angle measures. And here's how I'm going to show you how to do that quickly. So if we just go around the box, let's just look at all of our 105 degree angles where we can draw a bunch of our zigzags. Here in this zigzag, all these angles have to be 105. All the angles in by angle 4 have to be 75, which means this all has to be 105, and all of these angles would have to be 75. Okay, you guys answer these questions. Pause the video. When you come back, I'll have the answers. All right, here's all the work done. If you still have questions on where I came up with all these answers, make a note in your notes. Or if you're in the middle of class, come ask me right now. All right, that's all from me.